All right, so we've got a question here. Suppose the total benefits and total costs from an activity are respectively given by the equations. Benefit 150 plus 28q minus 5q squared, and the cost 100 plus 8q. So we'll start the first question. Write down the equation for the net benefit. Okay, so before we answer the question, this topic is on marginal analysis. Okay, you're just trying to find out how much should we produce so that we get the most the most revenue, okay, and the most profit, basically. All right. So whenever marginal cost equals marginal benefit, that's the amount of units you should produce. That will give you the most profit, basically. Okay. So in this question here, this this equation represents the benefits. These benefits can also be revenue. Okay. And C represents the cost. So that's saying write down the equation for the net benefits. So the net benefit, okay, it's basically how you get the net benefit. It's the total benefit producing a certain amount of units minus the total cost of producing a certain amount of units. Okay. As I said, this benefit can be revenue. Okay. So we write for the benefit our write our equation here 150 plus 28q minus 5q squared minus our total cost here 100 plus 8q. Okay. So this TB represents the total benefit when you produce a certain amount of units, and TC represents the total cost when you produce a certain amount of units. So we have to simplify this equation. All right, so we're going to write 150 plus 28q minus 5q squared. Then here we need to distribute this negative sign. We're not going to just write 100 plus 8q. So we're going to say negative 1 times 100, that is negative 100. And we're going to say negative 1 times 8q, get negative 8q. So we just operate with like terms. So here 150 minus 100, that will give us 50. 28q minus 8q, that will give us 20q. Minus 5q squared. Okay. This represents the net benefits. The benefits that remain after we take away the total cost. Okay. Those are the net benefits. Any question, madam? Okay. Then number 2, what are the net benefits when Q equals 1 and Q equals 5? So for this one, it's just a matter of substitution. When Q equals 1, we put it into our net benefit equation. So it's going to be 50 minus 20. So where there's a Q, we substitute it with 1 minus 5q squared. Where there's Q, we put a 1 here. So 20 times 1, that is 20. 1 squared is 1. 1 times 5, that is 5. So we have 50 minus 20 minus 5. 50 minus 20, that is 30. 30 minus, yes, 30 minus 5, that is 25. Okay. So these are the net benefits when you produce 1 unit. Okay. After you subtract the total cost from the total benefits, these are the net benefits. Okay. You can think of it almost like profit, basically. Okay. Because I said benefits can also represent revenue. So when you deduct your total cost from your total revenue, what remains is your profit. Okay. Yes. Then if we produce 5 units, Q equals 5. Just substitute 50 minus 20, open brackets, we put in a 5 there, minus 5, open brackets, 5 squared. So we have 50 here. 20 times 5, that is 100. Then 5 squared, that is 25. 25 times 5, that is 125. Okay. 50 minus 100, that's negative 50. Negative 50 minus 125, that's negative 175. Okay, so here when you produce 5 units, it means your total costs outweigh your benefits. So it won't be advisable for this firm to produce 5 units. Okay, because the net benefits are negative. It's like they're making a loss. Okay, number 3, write down the equation for the marginal net benefit. So there are two ways of doing that. Let me just scroll down. So the marginal net benefit is the same as don't know where I'm done. Marginal net benefit. There are two ways you can get it. The first way is you can derive the net benefit equation. Okay, we can derive this. Right, that's the shortcut method. So let's first derive, and I'll show you the second way. So marginal net benefit equals the derivative of net benefit. We're deriving the net benefit equation with respect to Q. Okay. So the net benefit equation was this one: 50 minus 20Q minus 5Q squared. Oh, and this is plus 20Q. Is a plus because 28 minus 8, so that is 20. Yes, 28 minus 8, that's 2, yeah. So here it was supposed to be 70. 70 minus 5, that is 65 here. Here it's 150 minus 125, that is 25 here. Okay, so yes, marginal net benefit, we're deriving the net benefit equation with respect to Q, right? So it's 50 plus 20Q 50 plus 20Q minus 5Q squared. So we derive this. Okay, when deriving a number without a letter, it disappears. 20, when we derive it. Madam Juliet, you're now comfortable with differentiation, right? I can just write the answer. I just write the answer direct. Excuse me. That's why even it's good we've revised this question here. But okay, for the I'll see if after I derive this one, you would try to derive the total benefit and the total cost one, so that because there's a lot of deriving in this course. Okay, so this is 20Q to the power 1. So you multiply the exponent with the number in front of the letter. 1 times 20, that is 20. You subtract a 1 from the exponent. 1 minus 1, that is 0. So it's like saying 20Q to the power 0. Okay. But any letter to the power 0 is just 1. So you don't need to write 20Q to the power 0. Okay. So you just write 20. Then here we're going to say 2 times negative 5, or 2 times 5 is already write the minus here. 2 times 5, that is 10. You subtract a 1 from this. 2 minus 1, that is 1. So remain with 10Q to the power 1. Is that okay? Okay. The other way you can get marginal net benefit is the total benefit minus total cost. All right. So in this question here, the total benefit here, can try to derive this one here. Have we got our answer? Deriving this BQ here. Have we got an answer? No. This, remember, you multiply, when you multiply the exponent with the number, subtract a 1 from the exponent. So try it again. And the number without a letter disappears. So, Mr. Twalumba, have you tried to differentiate? Okay, okay. Yes, because as I said, this class for 22 hours here, we have to learn these principles because there's going to be more differentiation in this course. So it's here now where we start now practicing. Madam Juliet, what's your new answer? The Q for 20, the Q disappears for 28. And then where's the plus coming from? It's a minus sign here. Mhm. Then this one also derive this one. This one is 28 minus 10Q. That's the margin of benefit. Yes, yes. Hmm. That's correct. So now subtract 28Q, 28 minus 10Q minus 8. What will you get? Since marginal net benefit is marginal benefit minus marginal cost. So you write 28 minus 10Q minus 8. What do we get? What answer you getting, madam? 28 minus 10Q minus 8. No, madam, you can't. The way I've done it, no, just like terms together. 28 and 8 are like terms. So you just subtract them. Okay, 28 minus 8, that is. Uh huh. 28 minus 8, that is 20 minus 10q. That's the marginal net benefit. 20 minus 10q. So that's the marginal net benefit. Okay, what are the marginal net benefits when q equals 1 and q equals 5? Okay, so substitute q equals 1 into this equation. What do we get? Wait, when q equals 1. 1? No, it will be 10. What about when q equals 5? Let's substitute q equals 5 into this equation. What do we get? Negative 30. 10 minus 10 times 5, that is 50. That gives us negative 30. As the marginal net benefit. So we can see that by producing at 5 units is not a good idea. Producing at 1 unit, at least we've got a positive marginal net benefit, and also our net benefit was greater than at q equals 5. Okay, part 5. What level of q maximizes the net benefit? So to find what level of q gives us the maximum profit, basically. Okay, so there we have to equate marginal benefit to marginal cost. Can equate marginal benefit to marginal cost. This is the at this point to give you the quantity that will give you the maximum net benefit, or you can equate marginal net benefit to 0. Okay. In marginal analysis, these are the two conditions you need to remember. Produce where MB equals MC, or where MNB equals 0. Okay. So we got our marginal benefit and our marginal cost when we derived. Right. So marginal benefit was 28 minus 10q. Marginal cost is 8. So let's equate this and find the value of q. Equate 28 minus 10q equals 8. Okay, this is where we're equating MB equals MC. What value of Q do we get? Then the other way you can do it, you can equate marginal net benefit to 0. So that would be 20 minus 10Q equals 0. So you can use either, you must find the same answer. So let's find the value of Q. What value of Q are we finding? Yes. Okay, because if we use the MB equals MC equation, you just take this negative 10 to this side, and this 8 comes this side. 20 minus 8, that is 20. Divide both sides by 10, Q equals 2. Madam Juliet, have you also found 2? Okay, we're not deriving. Okay, but wait, you are saying, what were you saying first? When deriving, you will go further because there's equal sign here. Yes, the operations are a bit different. Deriving, yeah, there's no need for for finding like terms and whatever. Yes. So when this frame produces 2 units, that's when they'll get the maximum net benefits. Okay, which is part 5 here. Okay, what is the value of the net benefits? So remember our net benefits equation. Net benefits was this one, right? With Q1, we got 65. With Q5, we got 25. So now let's see with Q2. So we substitute Q2 into the equation. Let's see. The net benefit equation, what I put. Oh, here it is. This 50 plus 20Q minus 5Q squared. Okay, so we say 50 plus 20Q minus 5Q squared. Okay, we substitute q with 2, so 50 plus 20 times 2 minus 5 2 squared. 20 times 2, that is 40, so we say 50 plus 40 minus, let me just get bundles first. All right. I was just kicked out by network. Yes. 2 squared, that is 4. 4 times 5, that is 20. 50 plus 40, that is 90. 90 minus 20, that gives us 70. Yes. So have you seen when you produce 2 units, our net benefit is the greatest. Okay. Mhm. If you try 3 units, you won't get a higher net benefit. Okay. 4 units also you won't get. 5 units, it's not even a good idea because the marginal net benefit was negative. Okay. Mhm. That is correct.